Hello viewers, in today's class we are going to discuss yet another important problem from inequalities, right? So in this class we'll solve or we'll prove this important inequality, that is e raised to x is greater than 1 over 1 plus x for all x greater than 0, right? So viewers, we have already discussed these kind of inequalities in our earlier videos, and we have already seen different methods how to prove these kind of inequalities, right? So in this class, we'll see how we can prove this inequality by making use of the concept of derivative, right? So viewers, the derivatives is an important tool in solving these type of problems, right? So to solve this or to prove this inequality, the first step is to frame a suitable function, right? So whenever we come across with these kind of inequalities, we should first frame a suitable function, right? So here let us frame a function, say f of x is equal to, here we have e raised to x, and if we take 1 over 1 plus x to the left hand side, we get minus 1 over 1 plus x, right? So with the help of the inequality itself, we can create our function, right? So here we'll assume f of x is equal to e raised to x minus 1 over 1 plus x for here we have x greater than 0, right? So now let us find out the derivative of f of x, right? So f prime of x is given by the derivative of e raised to x minus 1 over 1 plus x, right? Now see, the derivative of e raised to x is simply e raised to x, and then we have the derivative of 1 over 1 plus x, which is 1 plus x raised to minus 1. So we have e raised to x, and here we have minus, and we have minus 1 over 1 plus x whole square, right? So now the derivative can be written as e raised to x plus 1 over 1 plus x whole square, right? So whenever we prove these kind of inequalities, we first frame a suitable function, and then we find out the derivative of that function, right? So now our next aim is to test this function f of x for increasing function or decreasing function, right? So in order to test a function for increasing function or the decreasing function, we take the derivative, right? So now see, here f prime of x is equal to e raised to x plus 1 over 1 plus x whole square, right? Now see this term, right? So e raised to x is the exponential function, and this function is always greater than 0 for all values of x greater belonging to the set of real numbers, right? So the exponential function is always positive for all x belonging to the set of real numbers, right? So here we have x greater than 0. So obviously x greater than 0 are considered in this set, that is x belonging to the set of real numbers, right? So now let us consider this term, right? So here we have 1 over 1 plus x whole square, right? Now see, here we have x greater than 0, right? So x greater than 0 implies that we have to consider the positive values of x, right? And here we have the square term. So obviously a 1 over 1 plus x whole square is greater than 0 for all x greater than 0, right? So now we see that our derivative, which comprises of these two terms, e raised to x and 1 over 1 plus x square, right? So f prime of x is always greater than 0 for all x greater than 0, right? Because e raised to x is positive and 1 over 1 plus x square is also positive for x greater than 0, right? So our derivative is greater than 0, or f prime of x is positive for all x greater than 0, right? So we have seen that the derivative is positive, right? And from application of derivatives, we know that whenever the derivative is positive or the slope is positive, right? Because the derivative shows the slope of the tangent, right? So when the slope is greater than 0, it implies that the given function f of x should be an increasing function, right? And whenever the derivative is negative or less than 0, it shows that the function is decreasing, right? So in this case, the function f of x is increasing function because the derivative is greater than 0 for all x greater than 0, right? So now here quickly revisit the graph of increasing function, right? Because here we have shown that fx is increasing function, right? So let us take the graph of increasing function like this. This is f of x, right? So now let us take 2 points here. This point is x1, and let us take this point as x2, right? So the definition of increasing function, it goes like this: when x1 is less than x2, right, or x2 is greater than x1, then f of x1 should also be less than f of x2, right? So here f of x is an increasing function. We have taken 2 points, x1 and x2, where x2 is greater than x1. So obviously, if the function is an increasing function, then this distance or the ordinate is f of x2, this ordinate is f of x1, so f of x2 should be greater than f of x1, right? So now let us come to our function f of x, right? So here if we take x1 is equal to 0 and x2 is equal to x, right? So for this function, we'll take the first point as 0 and x2 as x, right? So when x1 is here less than x2, it implies that x1 is 0 and x2 is x. That is, x is greater than 0. So from this definition, f of x1, so f of 0 must be less than f of x, right? So f of 0. So let us first find out f of 0 by taking x is equal to 0 in this function, right? So f of 0 is equal to e raised to 0 minus 1 over 1 plus 0. So e raised to 0 is 1, 1 over 1 is 1, so this is 0, right? So f of 0 is 0. So 0 is less than f of x, right? So we have arrived at the conclusion that f of x is greater than 0, right? And f of x is e raised to x minus 1 over 1 plus x. This is greater than 0. And if we take this term to the right hand side, we'll get e raised to x is greater than 1 over 1 plus x for all x greater than 0. And this is our required inequality, right? So this is how, by making use of the concept of derivative and increasing and decreasing functions, we can solve, or we can prove these kind of inequalities. Hello viewers, in today's class we are going to discuss one important problem from inequalities, right? So in this lecture we'll prove this important inequality where we have e raised to x greater than 1 plus log of 1 plus x for x greater than 0, right? So in this lecture we'll see how we can prove this inequality for all values of x greater than 0, right? So to prove this important inequality, we'll make use of the concept of increasing and decreasing functions, right? So let us start. So to prove this inequality, the first step is to assume an appropriate function, right? So here we'll frame a function or a suitable function with the help of this given inequality, right? So let us assume that f of x is a function which is a log of 1 plus x minus e raised to x, right? And here we have x greater than 0. So the first step is to form a suitable function with the help of the terms which are given in the inequality to be proved, right? So we'll take f of x is equal to log of 1 plus x minus e raised to x, right? And remember here this log function is the natural log, right? So now we'll differentiate this function f of x, right? Because to apply the concept of increasing and decreasing functions, we have to find the derivative, right? So we'll differentiate f of x. So f prime of x is given by the derivative of log of 1 plus x minus e raised to x, right? So the derivative f prime of x is given by the derivative of log of 1 plus x is given by 1 over 1 plus x, and the derivative of e raised to x is e raised to x, right? So now we have the expression for the derivative of f of x, right? Now see, to apply the concept of increasing and decreasing functions, what we will do, we'll take this term that is 1 over 1 plus x, right? Now see, for x greater than 0, 1 over 1 plus x is always greater than 0, right? Because for all positive values of x, this term that is 1 over 1 plus x is always greater than 0. So now let us take this inequality as inequality number 1, right? So 1 over 1 plus x term is always greater than 0 for all positive values of x, right? Now see, here we have a term negative e raised to x. So what we will do, we'll subtract the term that is e raised to x on the both sides, right? So subtracting e raised to x from both the sides of this inequality, we have 1 over 1 plus x minus e raised to x is greater than 0 minus e raised to x, right? So this can be written as 1 over 1 plus x minus e raised to x greater than minus e raised to x, right? So let us call this inequality as inequality number 2. Now let us consider this term, right? Now see, we know that the exponential function e raised to x is defined as 1 plus x over factorial 1 plus x square over factorial 2, and so on, right? And we know that for all values of x belonging to the set of real numbers, e raised to x is always greater than 0, right? So whatever be the value of x belonging to the set of real numbers, e raised to x is always greater than 0, right? So if we multiply both sides by negative sign, because here we have a negative sign, right? So if we multiply both sides by negative sign, we have minus e raised to x less than 0, right? Because when we multiply the both sides of any inequality, then the direction of the inequality get reversed, right? So minus e raised to x is less than 0. So now this inequality can be written as 1 over 1 plus x minus e raised to x greater than minus e raised to x, and minus e raised to x is less than 0, right? So here we have minus e raised to x which is less than 0, right? So now this term is equal to f prime of x, right? So f prime of x is greater than minus e raised to x, which is further less than 0, right? So now this inequality can be written in the form of two inequalities, right? So the first one is f prime of x is greater than minus e raised to x, and minus e raised to x is less than 0, right? So if we combine both these inequalities, then we'll get f prime of x is less than 0, right? So now we see that the derivative of this function f of x is less than 0, right? And we know from application of derivatives that if the derivative of a function is less than 0, then the function is said to be decreasing, right? So this equation, it implies that f prime of x is less than 0 for all x greater than 0, right? So this inequality suggests that f of x, this function is a decreasing function. This is a decreasing function for all x greater than 0, right? So now let us consider the graph of a decreasing function, right? Suppose we have a decreasing function like this, right? This is some function, say y is equal to f of x, right? And let us take 2 points x1 and x2, right? So here we have x1 and this is x2, right? So this distance is f of x1 and this distance is f of x2, right? So our abscissa is x1 and x2, and the ordinate is fx1 and fx2, right? And here we have the origin 0, right? And we see that x1 is less than x2, right? So this distance is less than this distance, right? So when x1 is less than x2, then for a decreasing function, f of x1 is greater than f of x2, right? So this is another definition of decreasing function. So for any 2 points on the function or on the graph of the function, we have x1 and x2. If x1 is less than x2, then for decreasing function, f of x1 should be greater than f of x2. So we'll apply this concept to this function f of x. So for this function f of x, let us take 2 points x1 and x2, as x1 as say 0 and x2 as x, right? And we know that x is greater than 0, right? So when x is greater than 0, then by this definition, right, then by this definition f of x must be less than f of 0, right? So what we have done here, we have taken 2 points, x1 is 0, x2 is some x, and x is greater than 0, right? So when x is greater than 0, then the value of the function at x must be less than the value of the function at this point, and that is 0, right? Because this is the definition of decreasing function. So for f of x, we can write this value. So we have log of 1 plus x minus e raised to x less than f of 0, right? So f of 0 can be obtained by taking x is equal to 0 in this function, right? So f of 0 is equal to log of 1 plus 0, then we have minus e raised to 0, right? So here we have simply log of 1 minus e raised to 0 is 1, log of 1 is 0, and here we have minus 1, so this is minus 1, right? So f of 0 is equal to minus 1, right? So for f of 0, we can write here minus 1, right? So now what we will do, we'll take this negatives 1 to the left hand side and minus e raised to x to the right hand side. So we have log of 1 plus x plus 1 less than e raised to x, right? And this is our required inequality, and that is e raised to x is greater than 1 plus log of 1 plus x for all x greater than 0, right? So viewers, this is how by the definition of a decreasing function or the concept of decreasing function, we can prove these kind of inequalities.